Alright, quick video today on how to solve systems of linear equations. Today we are going to do it by graphing. Now, before we start, first thing you need to know is that once you solve a system, the solution must be true for both original equations. So, here's just a quick little thing. For -6, is this a solution to this system? Well, what you want to do is you want to substitute x and y back into both original equations. So we have 2 times 4 minus a -6. Is that equal to 14? Is 8 plus 6 14? Yes, it is. We'll try the next one. -3 times 4 plus 2 times a -6 is equal to a -24. Is that true? -12 plus a -12 is -24. Yes, it works. So, yes, this is a solution. Now, pause really quick. Try the next example. Is 2 comma -3 a solution to the next one? And if you said no, you'd be correct, because you substituted into the first one, and you're going to get a true statement. That's going to give you 12. But if you substitute it into the second one, you're going to get 2 plus a -3, which is not 5. It's -1. So this is no. It must work for both to be yes. So, what we're going to do today is I'm going to show you 2 different ways. When you use a graphing calculator, you are going to have to first get both equations into y equals mx plus b. So that's what we're going to do here first. Put both of these equations in y equals mx plus b. And this is what you should have. If not, you better go back and try to find your mistake. Because your graphing calculator will do this for you, but you got to tell your graphing calculator the correct thing to do. So let me go see. Here's my calculator. We have 3/2 x minus 6 into y1 and x minus 5 into y2. What you want to do is graph it. I like zoom 6 because that means I'm going to have a nice square graph, and we're going to see where these 2 lines intersect. Your calculator can find that intersection point right there because that is the solution to a system. Okay, so what you do is you press second, trace, and then number 5 is intersect. And then your calculator is going to ask you to do some stuff, find the first curve, second curve, and then guess. All you have to do is click enter 3 times here. And here you go. The solution is 2 comma -3. So that's our answer, 2 comma -3. And what you could do is you can go back and you can check, substitute these back in. But if you tell the calculator correctly, that is the right answer. Now, on a quiz or a test, I always recommend going back and checking your work because it's so easy to take 12 seconds to find out if you did it correct or not. And if you didn't, you erase and you move on. So, we've got 4 graphs that we're going to do today. To do this on a coordinate plane, you want to be as exact as you possibly can. Now, I'm probably not going to make you graph anything that's, you know, -1/3 x plus 5/3 or anything crazy for a starting point, because that could alter your results a little bit. Most of the time you have to do it by hand. It'll be pretty nice. So we have 2x plus 5, so we're going to go to our +5. And we go up 2 over 1, we go up 2 over 1, and the first line you do, you might want to do quite a few points because you want to have a real nice intersection point when you do this by hand. So I sometimes just go all the way across. And there we have our first line. And then our second line is -x plus 2. So what you're going to do is you're going to go to 2. And then you go down 1 over 1, and you see we're going in the wrong direction. But if we go back 1, look at that. We just put a blue dot on top of a red dot. That is our intersection. So we just sketch our graph. Don't forget to sketch the graph. And this right here is our intersection point that we want. That is the solution. So our answer is -1 comma 3. Remember, solutions to systems are coordinates. It's where 2 lines intersect. That's on the coordinate plane. So you must write your answer in a coordinate form. So number 2, the first thing you're going to need to do is graph those 2 and find the intersection. I'm going to let you do that on your own and see how you do. If you are more of a fan of y equals mx plus b, this is what you have. So the first one we have negative 2x plus 13. That's kind of tough because you're up here. So you might have to think to yourself, you're starting at 13 going down 2 over 1. That puts you at 1 comma 11. So you go down 2 and 1 more. Here's your first point on the graph. But it's totally fair because you can just, you know, imagine in your head where you're coming from. So we're just going to keep on skipping down 2 over 1, skipping down 2 over 1 until we run out of room for the first one. And then the second one, we have a negative 1/2. So negative 1/2 isn't too bad, okay? Like I said, I wouldn't give you 1/3 or 4ths or anything, but 1/2 isn't bad. And then you're going to go up 5, so up 1, 2, 3, 4, 5 over 2. That puts you right here. And then you're going to go up 1, 2, 3, 4, 5, and that's going to put you over 2. And you can see where these two are about to intersect. They're going to intersect right there. So here you go. You are at, follow it down, 3, comma 7. And of course, if you have time, you're going to go back and you're going to plug those 2 points in and make sure that they work. All right. Number 3. Number 3 is going to have something special happen to it. So is number 4. Number 3, you could do these by intercepts if you want, just so you know. So this one we're going to say that x is negative 3. And we're going to say that y is 1. And we get something that looks like that. Then you just look at your slope. It's up 1 over 3. So up 1 over 3, up 1 over 3. And you get a couple more points, down 1 over 3. And there's your first line. And now let's see what happens with the next one. We've got 2x equals negative 6, so x equals negative 3 again. And then we have negative 6y equals negative 6, so y equals 1 again. Hey, check it out. You just graph the exact same line on top of the other line. And when you graph 2 lines, that means it has infinite solutions. Okay, because any intersection point, this is a solution, that's a solution, this next point's going to be a solution, this guy back here is going to be a solution, any place, because they're intersecting constantly, because you just laid one line on top of the other. So whenever you graph the exact same line, that is infinitely many solutions. Last one. Again, we can see what's about to happen here. We have parallel lines, so what happens when we graph them? Well, if we start at negative 6 and we go up 2 over 3 and we go up 2 more over 3, we've already got an idea that this is going to look like that. And then your last one, we're going to do it again. We are going to go to a positive 2 and we're going to go up 2 over 3, up 2 over 3. And you should already know the answer to this without even thinking about it, but I just want to show you. They're parallel lines because they have the exact same slope and they have a different intersection. So are these 2 lines ever going to intersect? No, they're not, because they're parallel. So the answer to this is no solution. Alright, that completes our video on solving systems by graphing. Stay tuned for solving algebraically. That's coming up next, also known as substitution and elimination. Alright, Longo's out. See you.